and welcome to today's lesson on acid-base neutralization, where we will learn how different concentrations of acids and bases in different volumes can work together to neutralize each other. Remember, an acid is a substance that has a pH less than 7, and a base is a substance that has a pH greater than 7. And when they combine in the correct or with the correct concentration and volume, they can produce a neutral solution with a pH of 7. And then we'll take a look at how we can solve some different titration problems, which is the goal of today's lesson. So a little bit about acid-base neutralization. Now, as I said, when acidic and basic solutions are mixed, we have the positive hydrogen ion or cation of the acid and the hydroxide ion or the anion of the base that combine to form a water molecule or H2O. The anion of the acid, so what the hydrogen was attached to, and the cation of the base, or what the hydroxide ion was attached to, will come together and form a salt, which is defined as an ionic compound that can be formed by acid-base neutralization. And really, this is a simple double replacement reaction where we have two species that are swapping spots with each other. And in this case, we have water, which is formed during the reaction, and that's considered to be the precipitate. Now, as we work through these reactions, you will see sometimes that water is written as HOH, just so we can kind of see a little more clearly that the OH or hydroxide is coming from the base, and the H is being contributed from the acid. And it's important to note that 1 mole of hydrogen ions will exactly neutralize 1 mole of hydroxide ions. And this is important to note as we deal with different solutions that might have different pHs and different volumes. Now, when we're writing these reactions, it's exactly how we do a double replacement reaction where we have two species that swap with each other. And I'll kind of highlight this first one here. So we have an acid and a base, HCl or hydrochloric acid being our acid and sodium hydroxide being our base. These two to combine are salt and our water. So we have the hydrogen from the acid and the hydroxide from the base that get combined together to form our water. And you can see where those are contributed here. Since we conserve matter, what's remaining, a chlorine ion and a sodium ion, these will combine to form our salt, sodium chloride. And you can see where those combine as well. And the phrase for this is that acids and bases make salt and water. And some of these will look a little bit different. So again, with the acid, we have hydrogen. That'll combine with the hydroxide ion from the base to form our water. And whatever's remaining simply becomes our salt. Potassium being a positive ion, a +1. Sulfate being a 2- ion. So we have an anion and a cation. And we always write the cation first. And we would need 2 + 1 charges to get a +2 to balance the -2 here. So we get K2SO4 as opposed to just K. So we balance that with the 2 there. And that also helps to balance the water at the end here because we started with 2 hydrogens. And we'll take a look at more of that later. But this is saying that we have 2 moles of hydrogen, and that in order to neutralize, we're going to need 2 moles of hydroxide ions as well. Now in the third example, we have our HNO3 and our CaOH2. And again, we can kind of pick out where our water is here, and whatever's remaining becomes our salt, in this case, a nitrate and a calcium, these two will combine. We write the calcium first because it's positive, to form our calcium nitrate salt. And this will be true anytime we have an acid-base neutralization reaction. So in theory, if we were to combine the appropriate volumes and concentrations of hydrochloric acid with sodium hydroxide, what we produce is a solution of salt water, which, although not recommended to drink, at least in large quantities, is not harmful. So we take two substances that are extremely caustic and corrosive in hydrochloric acid and sodium hydroxide, two very strong acids and bases, which could be very detrimental to tissue if ingested. And when they combine and reorganize, we end up with salt water, which again is not would not be dangerous to consume. I'm certainly not recommending anybody to do this, but I find it interesting to note that this neutralization works in that manner. So a titration is a controlled process of neutralizing acids and bases. And it's mainly used to determine an unknown concentration of an acid or a base. Maybe we were to come across something or wanted to know exactly what a concentration of an acid might be. We could use a titration. As long as we knew the concentration of the base that we're going to use, we can determine what the unknown concentration of the acid is. Now, there's a little bit of a process to solve these types of problems. And first, as we had mentioned, 1 mole of hydrogen ions will neutralize 1 mole of hydroxide ions. It's important to note. So the moles of H plus need to equal the moles of OH minus in order to neutralize. Now, table T on the back of your reference table tells us that the molarity of the acid times the volume of the acid, that product has to equal the molarity of the base times the volume of the base. And that's abbreviated in your table. M sub A times V sub A must equal M sub B times V sub B. And we'll apply this here to a couple different samples and work through those so you can see how this is done. So in a titration, we have 20 milliliters of 0.15 molar hydrochloric acid. That's exactly neutralized by 18 milliliters of potassium hydroxide. Now, in our equation, we have 4 different variables, of which we're going to need to know 3 in order to solve for the other one. So I like to kind of pick these out in the problem when you see it. Now, the first part, 20 milliliters of 0.15 molar HCl. HCl, the H at the beginning indicating that this would be an acid. And this is listed in your reference table as well. So we have a molarity of acid, 0.15 molar, and a volume of acid. And we know that it's neutralized by this amount or volume of base. And now we can figure out what the concentration of that base was in order to neutralize that amount of acid. But first, we want to complete the equation for this particular neutralization reaction by writing the formula of each product. And we end up with potassium chloride and water, because we have the H from our acid combining with the OH to form our water. And what's left is the K and the Cl, which is our salt, potassium chloride. And those are our 2 products. Now we compare the number of moles of hydrogen ions to the number of moles of hydroxide ions in the titration from our substances here, HCl and KOH, and see what those mole ratios are when they are neutralized. And in this case, we have 1 OH to 1 Cl, so they are a 1-to-1 ratio, or they're equal. Now, to determine the concentration of that potassium hydroxide, we're going to look for the M sub B. Now, we'll plug in the other 3 values that we had just identified. We rearrange the equation and plug in and solve. we end up with the molarity of the base as 0.17 molar, and we round to the same concentration that we had with our acid. Now in this case, both the volumes are in milliliters, and this particular equation, it's fine if they're in milliliters. They don't have to be in liters, but they have to be in the same unit. They can't be in a different unit. Second sample problem. In a titration, an indicator is added to a flask containing 35 milliliters of HNO3 of unknown concentration. After 30 milliliters of 0.15 molar NaOH solution is slowly added to the flask, the indicator changes color. This is telling us that we've reached the end point and that the acid has been neutralized. So we'll write the equation for this neutralization reaction by writing the formula of each product. Now we know first thing we do, remove the water, the H and the OH. That's going to make our water. It's always one of our products. Remember, acid and base makes salt and water. And what's remaining, the sodium and the nitrate, is going to be our salt. Sodium being positive, nitrate being negative, we'll write sodium first, and it becomes sodium nitrate. Remember, nitrate salts are always soluble. Now we can try and find the concentration of the nitric acid solution. Now we have 35 mils of that nitric acid. That's the volume of acid. We know that we have 0.15 molar sodium hydroxide, so that's the molarity of the base. And we had 30 mils of that, which is the volume of the base. Now we'll plug that into our equation, and we will rearrange and solve for the concentration of the acid. You don't have to do this step, but just to kind of outline it, I think it looks a little bit easier, a little more straightforward. The molarity of the base comes out to 0.13 molar after we punch those numbers into our calculator. Now note that the concentration of the acid is a little bit less than the concentration of the base, but that's because we had a less amount of a stronger base, so we had to use more of a weaker acid in order to neutralize it. Otherwise, if it's the same amounts and the same concentrations, then they will neutralize each other. Now for the last one here, we have a titration. An indicator is added to the flask containing 10 mils of sulfuric acid of unknown concentration. So we have a volume of acid, and we don't know the concentration. So the molarity of the acid we do not know. Now after 200 mils of 0.4 molar sodium hydroxide, so we have a molarity of base and a volume of base. Solution is slowly added to the flask. The indicator changes color, which shows that the acid has been neutralized. So we're going to want to look for the molarity of this acid. Now we first want to write the equation for the neutralization reaction so we can determine the formula of each product. Now we have two H's there and one OH here, and that's going to make water, but we have an additional hydrogen here, and we only have one hydroxide. So we know we're going to make water, but we're going to have to deal with those moles in a second. And what's remaining is a sodium and a sulfate, which would be sodium sulfate. And this, since sulfate is a 2- and a sodium is a +1, we're going to need two of these. So when we write our product, we're going to get, well, I guess it's not in there. When we get our product, what we're going to get is sodium sulfate, which is balanced. And what this did, we had our NaOH and we needed two sodiums. So what we're going to do is put a 2 in front here, which will give us the two sodiums that we needed here. And it's going to give us the two hydroxides that we need to balance these two hydrogens. So we end up with sodium sulfate and water. This would be aqueous, and this would be in the liquid phase. Now, to determine the concentration of the sulfuric acid, we first are going to have to account for this 2-to-1 ratio of H plus to OH minus. We have the 1 there and we have the 2 here. So when we punch this into the equation, this is not included on your reference table, we're going to keep the equation the same as it is from the table, which is here. And we're going to multiply each side by the mole ratio of the number of hydrogens and the mole ratio of the number of hydroxides in our formula. In this case, this number for hydrogens happens to be 2, as we get it from the H2SO4. We multiply that times the molarity of the acid, which we don't know, times the volume of the acid of 10 milliliters, 10.0. And that has to be equal to the molarity of the base of 0.4 molar, times that volume, which was 200.0 milliliters, times the number of moles of hydroxide, which is 1. Now when we punch all this in, this gets rearranged. And what we get is a 4 molar solution of H2SO4. And what I'll point out here is that this concentration is 10 times as strong as a 0.4 molar concentration of base, and this is why it required 10 times as much volume of base compared to a tenth of that volume of the acid. And that's also due to the 2 hydrogens that we get from the H2SO4. So really this is 20 times greater due to the 2 moles of hydrogen ions in the H2SO4. If you guys have any questions on this, make sure you write them down and get answers when you can. Hope everyone has a great day.